This video is on the objective determine the p-value for a hypothesis test for the mean, but with the population standard deviation unknown, right? Sigma is unknown. So our test for the mean will be a t-test, right? We'll be having a t-score as our test statistic and working with the student's t-distribution with so many degrees of freedom. Now this is number 2, okay, so hopefully you've seen number 1, the first video on this objective. If you haven't, please watch it. So I'm going to go through this a little more quickly than the first one, do a little less explanation, but still, hopefully watching it will help you get through these kinds of questions. Alright, so again, if you're unfamiliar with the topic, want to see more about it too, you can click on More Instruction, look at their videos, their examples, their notes, and maybe they'll help you out. Alright, so here Curtis is a statistician who claims that the average salary of an employee in the city of Yarmouth is no more than $55,000 per year. Alright, so Gina, his colleague, believes this to be incorrect. So, her belief is that the average salary of employees in this city, all employees in the city, is more than $55,000. So, she randomly selects 61 employees who work in this town, Yarmouth, and records their annual salaries. The following data is from the study. So again, remember the null hypothesis would be assuming that the mean salary is 55,000, and this alternative hypothesis is what Gina believes, right? Her claim that the mean is more than 55,000. So you see the alternative hypothesis is a greater than statement. So this is a right-tailed test. All right, it's a right-tailed test. So when you calculate p-value, you're going to find the area to the right of the test statistic, and that's it. Right? There's no doubling like in a two-tailed test, like in the first video on this objective. Sample mean is 60 of these 61 employees is $56,500 per year. The sample standard deviation is $3,750, and they've already calculated the test statistic for us. All right, remember how to calculate that would be a t-score. Right, you take 56,500, the sample mean, subtract the assumed mean, right, the 55,000, and then divide by the standard deviation of the means, the sample means, which would be 3,750 divided by the square root of 61, right, that s over the square root of n. If you did that, you end up with approximately 3.12, right, a t-score of 3.12. All right, so now you can use the table down here. I'll show you how to use the table in a second. I'll talk you through it, but let me find the p-value for this test statistic using my calculator. All right, it's pretty simple. All right, so we're working with a t-distribution, right? So students t, so the horizontal axis is t-scores instead of z-scores, but they mean the same thing and pretty much. Bell-shaped distribution. The distribution of the means here would be a t-distribution with 60 degrees of freedom. Remember, they said the sample size was 61. So this is a t-distribution with 60 degrees of freedom. The t-score under the peak is 0, and our test statistic came in at 3.12. 3.12, so definitely above the mean. Right, here's the test stat, the test statistic. Now, remember how the alternative hypothesis was that the mean was greater than $55,000? So for the p-value of our test statistic is just the area to the right. It's just a right-tailed test. So the p-value in this case is simply going to be the area to the right of the test statistic. Right, and if it were a left-tailed test, it would be the area to the left of the test statistic. And if it's a two-tailed test, It's the area to the right of the positive one and to the left of the negative one. Or you could say to the right of the positive one doubled, or the area to the left of the negative one doubled. All right? Or however you want to say that for a two-tailed test. But this is only a right-tailed test. All right, so area to the right of the test statistic. Now, for area under a student's t-distribution curve, you can go to your calculator. I got my 84 here, 83, 84, I have something similar. Go to that distributions, and remember how normal CDF gave us area under a normal curve. Number 6 here in my menu, TCDF gives us area under a student's t-curve. Now, what is the lower value in this region? It's my test statistic, 3.12. There is no upper value, right? This is to the right forever, so I'm just going to put in some large positive number like 5 nines or something. And then what were the degrees of freedom for this t-distribution? 60, right? It was one less than the sample size. So this area is, very small. Right? The p-value for my test statistic is approximately 0.001, very, very tiny. About 0.1%. Right? And then to make decisions about, do I reject the null hypothesis or fail to reject the null hypothesis? Remember, you compare this value to alpha, the significance level. And if the p-value is less than or equal to alpha, you reject the null hypothesis. If the p-value is greater than alpha, you don't reject the null hypothesis. I would imagine that this would be less than or equal to any alpha I chose, 1%, 5%. Usually those are the values of alpha. So good chances, the chances are this test statistic is too far away from my liking, and I would reject the null. But that's not what we're asked here. We're just asked, hey, what's the p-value? Right? Very, very tiny. Definitely less than 1%. It's less than 0.5%. It's like 0.1%. Right? So very, very small. Now, how we're going to use this table is another story. Right? Because the table here gives us critical values. Remember the critical value method? And to determine how small our p-value is, we're going to see where our test statistic falls compared to these critical values. Now, I mentioned this was a t-distribution with 60 degrees of freedom, so I'm in this 60 row. And for a t-distribution with 60 degrees of freedom, a t-score of 1.296 has 10% to the right. A t-score of 1.671 has 5% to the right. A t-score of 2 has 2.5% to the right. And all the way at the end here, a t-score of 2.66 has 0.5% to the right. But where does our test statistic fall? 3.12 is to the right of all of these, right? 3.12 is greater than 2.66. So the area to the right of 3.12 is going to be less than this 0.5%. It's going to be even smaller. And you saw it was like 0.001. And that's what we're going to say. All right. So again, down here. Now the probability of, now how do I say this in terms of the right-tailed test that we have here? The probability of observing this t-score or more, well, that would be right-tailed, is between 2.5% and 5%. No, it's not. We said it was less than 0.5%. Less, it's just around 0.1%. So not that statement. The probability of observing this test statistic, or that would be a left-tailed test if you're just doing that or less. So this isn't even the right direction. The probability of observing this score or more, that'd be a right-tailed test, is greater than 10%. No, it's not. Right? We saw it was about 0.001, very, very tiny. And the probability of observing this or more, which would be a right-tailed test, is less than 0.5%, which is what we saw. Right? When I did my calculator, when I looked at this table, we can see, that p-value, that area to the right of 3.12, definitely less than 0.5%. So that's the only one that makes any sense, the only one that fits our values, and that's it. And that's all they're asking us for here. They're not asking us to reject or fail to reject the null hypothesis, that'll all come later when they put all the steps together. Okay? All right. So again, done a couple videos on this now. Again, you can use your calculator to find the p-value and just use that p-value and figure out which statement is correct in the choices, or use the table, whichever. They should both be relatively simple. Yeah, so hopefully you watch my video. Hopefully watching these videos helps you when you work on these questions, these kinds of questions on your own. And thanks for watching.